Good afternoon, everyone. My name is Ronan Doorley, and I'm a research scientist with MIT City Science. And I'm going to talk to you today about proximity of homes, workplaces, and amenities. So transportation in the USA accounts for more carbon emissions than any other single source. And we usually tend to think about technologies like electrification and autonomy as being the solution to this. And I think these technologies definitely have a role to play. But let's first take a step back and talk about why we make so many of these motorized trips in the first place. So the separation of industrial, commercial, and residential areas from one another is really a modern idea that was only really made possible by the advent of railways and later road networks. And this has really led to the kind of auto-centric sprawl that we see, especially across a lot of US cities, whereas cities that developed before the automobile tended to grow more organically at these networks of walkable communities. And I think today there's kind of a growing recognition that in some ways we need to start moving back towards this idea of living in mixed-use communities where we have all of the amenities of daily living within a walking distance. So I'd like to talk about some of the tools and methodologies that we're developing in city science in order to model and even design these kinds of walkable communities, starting with Kendall Square as a test case. Okay, so let's first talk about how people are currently moving around in Kendall Square. So kind of depending exactly where you draw the boundary, there's around, say, 57,000 people commuting into Kendall Square, but they live somewhere else. You've got about 4,000 people who live in Kendall Square but commute out to somewhere else, and then about 2,000 people who both live and work in Kendall Square. And these groups of people have very different mobility behaviors. The people who are commuting in are driving, on average, say, about 9 miles a day for purposes of work, compared to about 4 miles a day for the people who are commuting out of Kendall Square, and then less than 1 mile a day for the people who both live and work here. And this is just for between home and work. When we talk about other trips to amenities, what we call third places, so trips to restaurants, grocery stores, and so on, it turns out all three of these groups actually drive more for those types of trips than they do between home and work. So if we come back to Kent's thought experiment, what if all of these people who are currently commuting could instead both live and work within Kendall Square? So a simple calculation can tell us that the total miles driven for commuting purposes would drop off dramatically. And then if we also include local usage of amenities in this intervention, then similarly the total miles driven would drop off very dramatically. And between the reduction in driving as well as the higher efficiency of urban spaces, dense urban spaces, we could see up to almost 6 tons of CO2 per person reduction per year. So this is a really large reduction, but this is also quite an extreme scenario. And in order to actually move towards this types of outcome, there are some really difficult challenges that we would need to address. So first of all, we need to be able to provide the right types of housing for the people who currently work in Kendall Square in a way that's affordable and attractive. We need to provide the right types of local jobs for the people who already live here, and then provide enough of the right types of amenities to support this new population. So some of the other talks today, and the next talk by Maitane is going to address housing. So I'm going to focus on these other 2 points, starting with providing jobs to the current residents. So it's really important that we're able to understand what types of jobs are actually accessible or suitable for a particular population. Because if we just provide jobs that aren't necessarily suitable for a population, then it's not going to reduce commuting, and we're actually just going to have more people commuting in order to take those jobs. But this is something we can model. We can actually model the closeness in skill level between any 2 jobs using just open source data and come up with a kind of matrix of kind of job skill proximity between different jobs. And we're actually using an approach like this, for example, in East Palo Alto, in order to model and predict the impacts of different industry development scenarios. Today, there's a lot of people who commute out of East Palo Alto for work, and so we're interested in finding whether the right mix of industries, if brought into the area, could actually provide better jobs for the locals and also reduce their need to commute out and reduce the total amount of commuting. And by modeling the likely job-to-job transitions that would happen in any particular industry development scenario, we can then start to understand in each scenario how many of the newly created jobs could be filled by the locals versus how many of those jobs would have to be filled from outside the community, which would lead to more commuting and potentially even displacement pressures on the population. And we're finding that the right choice of industry can have a really significant impact on this. Okay, so that's matching jobs to people, but as we saw, that's not enough because most of the driving is actually for those kind of third places trips. So we also need to make sure that we have the right mix and capacity of amenities so that people don't need to drive for those third place trips. And so the first thing I think we need to do is to understand what amenities people actually need and in what capacities. And one way we can get at this is to look at the amenities that people are currently using, regardless of where they are. So in this visualization, we're looking at SafeGraph data of the Kendall Square residents making trips to restaurants and other eating places. And we can do the same kind of analysis across a whole range of amenities and start to understand how many of each amenity or what capacity of each amenity we would need per capita in order to support the population. And some of these amenities are going to be more relevant than others, kind of depending on the stakeholders. But once we've kind of decided on these benchmarks, we can actually analyze the performance of any particular place. So starting with the data on the residents, we can kind of infer the demand for amenities. We then combine this with the road network and the actual locations of the amenities and calculate how many of each amenity type are accessible to each residential location. And then from there, we can calculate the accessibility metrics, where here blue is indicating there's sufficient access to each amenity, and then red is indicating that there's some kind of a deficiency. And we can also do the same thing in 3 dimensions, where we take into account different usages on different floors, as well as potential three-dimensional mobility patterns both within and between buildings. And we can also see how any kind of new development would impact all of these metrics. Okay, so clearly there are a lot of challenges in terms of achieving both live-work symmetry and local use of amenities. But as we saw, there is a huge potential for carbon reduction if we kind of move towards these ideals. And not to mention all of the economic and social benefits that would come from having more walkable and vibrant communities. Thank you very much, and I'll pass it over to Maitane, who's going to talk about hyper-efficient places of living.